So in this last part of the lab, we're going to be using the motor transient VI, and you can see that it's already open in the window behind you. You have three parameters to select: command voltage, sampling frequency, and time window, along with the A to D range. Make sure to select that appropriately, and the file path and the save data icon. Make sure that that's highlighted green and give it an appropriate name. So we're going to name it 4 volts here just because that's the command voltage we're going to put in. So if we select a command voltage of 4 volts, a sampling frequency of 100, just arbitrarily chosen, but you will want to select it better, and a time window of 10 seconds. That will allow it to spend 10 seconds going to the steady state of the step response, and then 10 seconds going down from it. Now, note that the cable that was originally plugged into filter on here needs to be connected to the channel 0 D to A converter. This is just so that the command voltage will be appropriately recorded. Make sure you set this box to EXT instead of INT, because we're using external control, not the internal control. And it is on with the power supply providing power to it. So when you click run, you'll note that the motor begins to spin up, and it will spend 10 seconds being driven by that step voltage response, and then the power will be shut off, and the step response back down will be recorded for another 10 seconds. At the end of that, the screen will display the recorded data, with the black line being the command voltage. You can see that that's 4 volts. The blue line being the armature voltage, that would be 0.7 times the command voltage. And the red line being the tachometer generated voltage, which can be converted to RPMs from the previous steps in the lab where you've defined the constant. Now, one thing to note is that usually for the first data set, you'll want to just throw it away and then rerun the trial. This is mostly just because the VI will occasionally not start the step at the appropriate time, and you'll get some slightly skewed data as a result. But again, this is only for the very first trial that you run with the motor transient VI open. You'll also record the data for this at several different voltages, and make sure that you save them under different files so you can analyze their transient responses moving forward.